Okay, cool. Um, right. I
So,
will. Oh,
welcome
can I
أبو-
guys go?
welcome خليل. Yeah. أنا بس بدي أقول welcome خليل and thank you for joining us today. Khalil can one of one of the AI engineers that I had the chance to meet over LinkedIn. I think Khalil, it's been like 4 or 5 years back, and we were both just trying to explore more about this field. So and Khalil was studying in an esteemed university AI in London. هلا إن شاء الله هو راح يخبرنا كل الديتيلز أكثر عن هذا الموضوع. So yeah, it's been like since there, and now Khalil is working as a senior AI engineer at Firemind. I can't say much about this, so I'll leave the floor to you. Thank you, Khalil, for joining us.
Yeah, thank you, Lara, for having me. I will share my screen and then we can kick it off. Okay. Can you give me permission to share my screen? Can I do it now? Yes, I can do it. Okay. Can you guys see my screen? Yeah.
Yes.
Yes, yes.
Right. Okay. Okay. Yeah. Thank you, Lara, for having me. As Lara were saying, me and Lara met over LinkedIn. I think 4 years ago while I was studying. And then from there we just like had the chance just to keep in touch, and we both like always exchange ideas and learn from each other. And then yeah, we met in person as well in Beirut as well last year, I think, BDD as well. And yeah, so my name is Khalil Adib. I am an AI engineer at Fireminds. So Firemind is an AWS consultancy, AWS partner. We are in the top 1% club from the partners in the worldwide. We are an advanced partner. What does this mean is like AWS usually they don't do the work themselves. So like customer comes to AWS to do some work related to anything related to cloud computing. So they send them to partners, and then we are one of them. 2023, we won the UKVI Rising Partner of the Year. Last year, we were second to NVIDIA in the GenAI tooling in Las Vegas in reInvent, which was insane. Like we came last to NVIDIA, and you know NVIDIA, and we are NVIDIA partner as well. And then we are partnership with Anthropic and other model providers as well. So we specialize in AI, ML, everything related to data migration, data building, data pipelines, data warehousing, and all of this kind of stuff. And recently, obviously, last 2 3 years, the GenAI, and we do normal AI stuff as well, and ML standard traditional ML stuff. So that's basically it from my, I would say, like the work wise. Before that, I studied computer and communication engineering (CCE) in IUL in Lebanon. I did that for 5 years, and then I had some software engineering experiences through internships and some like really short period of time working as a software engineer in Beirut. Then, in 2000, I think 2019 or 2020, all of what happened in Lebanon, I decided to leave Lebanon. The all of the kind economical situation. So I came to the UK and I did my master's in AI in at City University of London, one of the well-known universities in London, in the field, especially in the field if in the AI, like specifically in the cognitive side of AI and reinforcement learning. And then yeah, I graduated with a distinction, and then after that I got introduced to the cloud world, and then I started doing some certifications related to cloud computing, AWS, all of the certifications, and I've met one of the directors for the company that I work for now, and then I've been with them like almost three years now, something like that. So yeah, that's in a nutshell, like what I do and how I got where I am now. And when Lara messaged me about doing something related to, and hopefully, guys, you are comfortable with me speaking in English, and then I don't mind speaking in Arabic as well, um, if that makes sense. So, what do you think, guys?
Um, for me personally, I don't mind. I think some of the members would prefer mix. Please, guys,
Okay.
feel free to drop it in the chat, and Khalil will make it. إذا حدا عنده أي
Yeah.
مشكلة بالإنجلش just let us know.
Okay.
Okay,
Okay.
so feel
Oh,
free to do it as you like. Okay, English then.
okay. Okay. So yeah, when Laura messaged me first to do something related to like present something in recent trend and stuff, and then the first thing that came to my mind is reinforcement learning with large language models, and obviously, we know that that RL, like they already been used like using from OpenAI before in LLMs, but we can kind of, and then we know DeepSeek what they did to do like to create a reasoning model similar to the O1 model from OpenAI, and then they made it open source, and then everyone had access to the paper, and like they open sourced everything. So I thought I can just like make a session about it, and usually, it's like obviously it's not the first time that I do such sessions. So usually I try to make it as conversational as possible because otherwise I would be sitting here speaking for 45 to 1 hour without and then hopefully you won't get bored. And if we just do it interact, like if it can be an interactive sessions, you will learn the most from it. So feel free to interrupt me, ask me any questions and stuff. So. Yeah, so like with that being said, the subject for today's session is reinforcement learning with LLM. Um, the outlines, I would say, I'm gonna do like a small introduction and I would say recap from what we know, and then why we are talking about this, and some just like to give some definitions and just like to make sure everyone we are all aligned and then we are on the same page. Then I'm going to talk about LLM agents and model trends in 2025. And you'll see why this is important as well, and why RL is one of the most important trends in 2025, specifically for the LLM world. Large scale RL for LLMs and hands-on lab. Actually, I won't go and do any coding, but I have a notebook, which I didn't write the notebook. I got it online, but we can kind of go through it really fast, and you can run it. I'll send the link later. You can run it on your own, and then I would kind of explain what we are doing exactly there, and then we will finish this session with a Q&A session, Q&A sections. And if you have any questions or even if it is not related to the actual content, we can just have a discussion, but hopefully it's related to AI. So yeah, that's it. Okay, so introduction and recaps. So first of all, as I said, I'm gonna try to make it conversational. Yeah. We have a lot of we know that LLM is taking the world by storm, right? But and then the LLM, the idea of large language models is previously it's not like something or language modeling is not something new. What do you know about language modeling, guys? Have you heard about this term specifically, or what do you know about NLP before large language models? No answer? Okay. So language modeling is basically the way that we can learn the statistical distribution or statistical probability for the language or the words that we say usually. So, for instance, you can say using something called rule of chain, I think. Well, we all studied probability in like in high school or in university, where like probability of A given B or probability of action A happens given that action B happened is equal probability maybe to A given B given BC or A given BCC, something like that. So it's just to make it more clear. So the probability that, for instance, of this sentence, hi, my name is Khalil, or my name is Khalil, is like maybe 0.001, which is kind of high probability, while the probability of something like hi, name I Khalil is really low because it is statistic because usually in our conversation we like no one like if I say this in front of anyone they will immediately know that I said something wrong grammatically or even from the like or something like I ate my cat, like usually no one eats his cat, so there is something in the meaning is wrong, so it's gonna get like low probability. And we used kind of all of this. probability learning to kind of learn the how we can, I would say, even like try to predict the next word given all of what we know previously. But the LLM or the transformer paper came in 2017, and the authors provide the authors presented a, I would say, a new architecture, neural network architectures with mainly two parts, encoder and decoders. And so they kind of, the idea was like to do sequence to sequence, and then mainly they focus on the translations, like to like successfully translate from one language to another with really high precision. And then, as I said, it has two-part encoder and decoders. So, and then after the paper that came out, people started doing research more about it. And then some people, for instance, Bert from Google, they just took the encoder part alone, and then they started doing something like a classification on a sentence or trying to predict the missing token um, within a sentence and stuff like that. And then other people start using only the decoder part, which we call it the auto-regressive language modelings. And all of the kind of new LLMs nowadays, like ChatGPTs, Anthropic, Claude, Mistral, all of this, I mean, and Gemini, all of these stuff, they are like auto-regressive language models, which means they only use the decoder parts, and then the input would be a set of sequences, and then the only goal of the transform or the this architecture is to predict the next token, and then after that, the next token will be fed again to the input sentence, and and then this process will carry on until we reach something called end of token or end of sentence, and this is usually something that being specified like by the people who will train that models. So as you can see on the screen, I have an example. Let's imagine that because it's not a session related to explaining what's happening inside the transformer, but rather than just like give a small recap about this. So let's say, hello, my name is Khalil, and then it will go through the model black box. And then the model black box, the model under the hood will try to predict the probability of next token. And then as you can see we have different kind of probability. And then the output, it's going to be a vector, as I said, with probability for each token, and the length of that vector, which will be equal the length of our vocabulary that we used initially to train to train the model. So the task again is predict the next token steps. Tokenization is the way we convert the actual sentences to something that the computer can understand. It's a mapping between sentence and a numerical representation, like a value, key, something you can put this in your mind for now. Obviously, like I can go like a lot deeper into each one of this in the screen, but again, it's not. We are not trying to actually explain what's happening inside, but just like we tokenize it, we feed forward in the networks, predict the next token, and then we simple the output. And then just to give you an idea, when we say simple, is like when you use like I think like most of you have interacted with any of the API providers before, and then there are some parameters that we can use, such as temperature, top P, top K, and all of kind of stuff. And then each one has something to do with the sampling. So, for instance, if you put the temperature really high, the model will kind of try to not pick the token with the really high probability, but rather not like give give the chance to less likely token to be in the next sentence and stuff like that. So, and then the last phase is the tokenize, which stands for converting the predicted token um, to like a human readable sentence. And by the way, at training stage, we only use the first three steps: tokenization, feed forward, and predict the next probability tokens. And then after that, a loss will be computed. But at inference stage, we use all of them. Does anyone have any questions so far? Go ahead.
Yes, yes, Khalil.
Yes, yes, please.
Yes, yes. Now your explanation is about the base LLM or the full LLM because
So what do you mean?
you said these three steps are essentially for LLM. For example,
Yes.
there is a phase, as I saw in many article,
Yeah.
they link some expert from
Yeah.
multiple fields, and they
Yeah.
try to train them to reply as a human. So
Okay.
you did not mention in this phase, or this is the base LLM you are talking now?
I think you're referring to the post-training and pre-training.
No, no. They said after having a base LLM,
Yes.
they start to train the model to reply as a human. For example,
Yeah.
they collect, for example, mathematics, physics, and from all fields, and they start to learn the model to reply. For example, what is the distance between sun and earth? And they said,
Yeah.
no, you should reply as this, not to continue the
Okay, so
phrase.
I think you're referring to the pre-training stage and post-training stage,
Yes.
which by itself it's like a really big topic. And then I will mention some of the post-training in the next slide where we used
Oh, okay.
RL as well. But essentially, this idea can be used in both because, as I said, it's like the first three steps is gonna be used for the training only, and then computing the loss, and then the full stage is gonna be in the inference. So it doesn't matter if the model is trying to if it is the base model that is trying to complete the sentence, or if it is like a assistant-like model that has been trained on a supervised fine-tuning data. So to answer your question is like this is like a general overview, and these steps are happening in both sides, I would say. Does that answer your question?
Okay, thank you.
Right, cool. Um, Going to talk about the reinforcement learning as well, and then hopefully, so just like to give you an idea what is reinforcement learning, and then it is not something really I would say new, and then like in fact, reinforcement learning was like one of assume like in the early days of artificial intelligence, like the reinforcement learning was even before trying to do like a neural network and stuff people, especially from the cognitive side of research, people were trying to, for instance, teach dogs or teach animals to perform or to behave well by giving them something called rewards. And then, like you say, like if anyone of you have like dog or cat or any like animals, if you like, for instance, if you want your dog to do like to sit on the ground, you can reward the dog by giving him like a food or something every times the dog like follow your instruction and then sit on the ground, and then with time you will see that the dog is learning from this interaction with you that if he sits on the floor he will get rewards for that. So this is the kind of the idea of reinforcement learning by reinforcing the agents to do what you want based on the reward that you specify. So as you can see on the screen, we have this small diagram where like we have, I would say, few important things to take into consideration. We have the agents, and then the agent can be anything. The agent can be robots, for instance. The agent can be system software that is running and then trying to do something, or animals, or anything. And then we have an environments, and the environments is the word you specify that as well based on your system that your agent is trying to interact with. For instance, if we have a robot and then we want to kind of train a robot to do reinforcement using reinforcement learning, the environments for the robot would be the actual word, like the actual physical word, and the agents, as you can see, will interact with the environment and by taking actions. And actions, again, for the robot example, the action can be move forward, move backward, hold something, I don't know, call, use a phone, any action that you can specify. And for each action that the agent will take in that environment, two new things will be produced. The first one is the reward function. So you specify that as well. So like you can give a reward, like good reward for the robot. If the robot try to be helpful, you give him like maybe +1, +5. And then if the robot does something really bad, you give him like -5. And then on top of that, there will be something called a new state, which means like if the robot, for instance, pick up something and then just put it on the floor, the new state is like that thing is on the floor, and then the reward function is really bad. And then there is something called policy. And the policy is I would say, kind of, if I want to put it in, like the policy is like, the thing that the robot will refer to in order to take actions, if that makes sense. And based on that reward and then the new state, the robot will, or the reinforcement learning agents will try to optimize that policy to maximize the cumulative reward function. And then this is important because I say cumulative, not like the like straight reward function. Because, for instance, um, an agent can do actions on the short term will give the highest reward, but in the long term it's gonna be not gonna give the highest returns, if that makes sense. So like if an agent takes like must take 10 actions, and then let's say we have two paths. One path, if the agent takes that, he will get like maybe 100 as a reward at the end. And then the other one, in the first few actions, he would take like uh, 50, and then for the last five actions, he won't take anything. So the agent has to optimize his policy in order to get the maximize the cumulative reward functions. And then this is happening through trial and error. So it's like the agent must like see the same environments and then try to interact with the by trying to produce the actions and updating his policy through many trial and errors. Like, just to give you an idea, that hopefully some of you heard about AlphaGo, which is the DeepMind in London in 2016, and before that they were trying to build an agent that can play a game called Go. It's kind of similar to the chess game, but is much more complicated because the space of possible environments is huge. Like it is massive, and the agent that they trained, he played with himself more games that the entire Go players played across the all of history, if that makes sense. Um, and then eventually the AlphaGo agent bet like he won against the world champion. And there is actually like really cool documentary, sorry, on YouTube on DeepMind channel. You must like watch it because it's really cool. So yeah, that's like I would say not a reinforcement learning in the nutshell, and it is being used across multiple industries, not like only like because some people think that reinforcement learning means only robots or something. It's being used in like for instance something related to environments, how we can have like an agent to save more energy using reinforcement learning. And any application, I would say, with an environments and action can be trained using reinforcement learning. Does anyone have any questions so far?
I don't have a question actually, but if you can send us, please, the documentation you mentioned right after the meeting. So I
Yeah,
think
yeah,
some of the members can have it. Yep. Thank you.
yeah, yes. So it's not documentation, it's like documentary. It's like an actual
Yeah.
video. You can watch it. It's really cool. It's really nice. And actually, if you, yeah, okay. And then before like actually trying to talk about the deep seek stuff and the reasoning abilities, we have like I think as again most of you heard about RLHF, and then it's kind of the moment in time when OpenAI used reinforcement learning to produce us an assistance, because before that we only had auto-completion machines that given an input sentence, the machine will try maybe to replicate or try just to predict the next token. And most of the time it was without any meaning, right? Um, I will go through this like really rapidly as well. So OpenAI, what they did is they used reinforcement learning and human in the loop. So what they did is like they hired a lot of human annotators um to first of all they fine-tuned the step one, and this is again after the pre-training step. This is the whole thing that you can see on the screen is post-training. Step one is to provide fine-tuning. They asked labelers to label data sets given an input sentence, try to complete that sentence. That's it. And then it should be like if the answer should be short, it should be short. If the answer should be long, it should be long. And what they did is like they took that base LLM, which is the results from the post-training stage, and then they fine tune that model using supervised fine-tuning. So we can end up with something called supervised fine-tuning models. Step two is like they use something called the reward function. And again, what they did is like using that supervised fine-tuning and then using the same prompt, they ask the model to produce multiple answers, and then using a human annotator, they ask the human annotator, given that prompts, please can you kind of rank these answers from 1 to 5, or can you say which one is best and stuff. And so they end up with another data sets. So like the input would be an input prompts, and then the output would be multiple answers, and then each one with a rank. Like this one would be the first, this one would be second, and stuff like that. They trained a reward function to actually judge the output. So like given that prompt for the base LLM, can you generate me something? And then that something that has been generated will be given a reward function. So if it is good, if it is following the human alignment stuff, like if the LLM is being helpful, the LLM is actually replying in a like a good in a good like try kind of conversational manner, the LLM is getting like really high rewards. Step three is actually optimize now the policy. So the LLM will now try, given a prompt, generate an answer, get a reward function, use that reward function to optimize its policy. To always kind of, we are forcing the LLM to reply to us in a conversational manner. So that's why when you go to ChatGPT, you can see when you say something, ChatGPT is being polite with us. ChatGPT doesn't like if you say, "Can you teach me how to do a bomb or something?" Like 99% of the time, the ChatGPT will refuse. Obviously, there are some, we call it prompt injection, where like you can. I saw online some people say like if you don't teach me how to use a bomb or something, my grandma will die and stuff. So there are always a way to do prompt injection, but this is kind of the way that they used reinforcement learning and with human feedback in the post-training stage to get a conversational and as AI assistance. In the nutshell, again, do you have any questions related to this? Okay, cool. Um, Moving to talk about the LLM agents and model trends in 2025. Okay, this stuff I got it from OpenAI. So OpenAI kind of like put a plan how we can kind of progress in the building these LLMs. They put five levels, which they think when we do them, we will be like maybe really near AGI, artificial general intelligence. Level one is building actually chatbots, AI with conversational language, and then I think this is what they did in 2021, late 2021 or 2022, where like we kind of have now an AI assistants on our phones and stuff. We can have a conversation with them like anytime we want, and the LM is being most of the time helpful. Um, Level two is actually building reasoning models with COT, which is a chain of thoughts, and we reach kind of human level problem solvings and a lot of benchmarks. And this like we are seeing over like the model can now actually you can see how the model is thinking or building a step-by-step plan to execute or to answer your questions. Level three is actually building agent and system with tools, and this is kind of the main trend in 2025. Well, like our agents now can interact with the external worlds by using external tools, and then these tools can be anything like calling an API, reaching a database. Maybe even now, literally, you can connect LLM to your house. If you have a smart house, you can say, "Please, can you turn on the I don't know, the AC? Please, can you do X, Y, and Z?" If the LLM have access to these tools, the LLM can and will execute the tools based on your request and stuff like that. Level four, which we currently again currently we're like in level three now. Level four is innovators, because what we have now is like the LLMs nowadays, they don't innovate, they don't come up with an idea from scratch. Like most of the ideas that the LLM will come with is from its training data. So we didn't reach a level where like the LLM can come up with something new. Level five is organizations, which is one of the it's really hard task to do. Like the LLM can organize and work in kind of like big organizations, and can interact with different tools, different other agents, or even other persons at the same time, and trying to be multitask and execute and learn from the environments at the same time. This is level five, and then maybe after that we kind of will reach the AGIs according to OpenAI, and then you can go and take a look at this link in here. You can maybe read more about it. Um, so large, then the trends in 2025. The pre-trained models, as I said, we have before we reach the like when any company wants to actually start and training their own LLMs, what they do is like they crawl the whole internet. Basically, there are some there are like some really big non-profitable organization that essentially crawl the whole internet every month. And what these companies do is like they take this crawled data, and then they do something called the pre-training stage, where like they batch the inputs, and then they just make the LLM try to predict the next token. That's it, without any reinforcement learning or supervised fine tuning. The problem with that is it's really expensive. It's like really, really expensive to train a 500 billion um, parameters model on the whole internet every month, and then it takes a lot of time. So most of these LLMs can take almost 1 year to train for one token only. Imagine, it's like really expensive. It's not only the cost of the compute, but it's actually the cost of the engineers, because the engineers who will be working on this, they are kind of in the top 0.1% of engineers worldwide. They are like the really smart people, and then they kind of you have to pay them a lot in order to convince them to work for you. And then you have the environmental price as well, because when you hire all of these GPUs, you are wasting a lot of energy. You need like a lot of water for the cooling, because this is machine will get hot, will produce a lot of. You have to cool them in order to be able to use them in the future, and all of this kind of stuff. RLHF, as I was describing the way that OpenAI and after that a lot of companies used reinforcement learning with the human feedback to kind of create an assistance, but again, it needs time and it is expensive, and it's not a true reinforcement learning, because there is not actually a planning or um, essentially the LLM is learning from a reward function that has been being used from a human annotators. It is expensive because you need to hire a lot of annotators, and then it needs time as well because you need to hire a lot of annotators, annotate them. After that, make sure the output is because what these company do is like they hire a lot of annotators, and then for the same prompt, they make multiple annotator to annotate it, and then they compare the results because they just want to make sure reduce bias. Um, and the other trends that we are seeing is synthetic data, which is, I would say, really good for distillations. I think this is going to be like a topic for other sections session as well. Essentially, distillation means like we use big model, teacher model we call it, and a student model, and then we make the student model learn from the teacher model. And usually, like 100% of the time, the student model is the small model. For instance, you can get OpenAI or any open source large model that is expensive to run. And then you have some data. What you do is like you make the teacher model to annotate that data, and then you take that supervised fine-tuned data, and then you, again, using SFT, you fine-tune the small model. And then in this case, the small model, can be Llama 8B or something, or even Llama 1B, be really specific at this case. And then there are a lot of cases where the student model reach the same accuracy on that data set as the teacher model. The problem with synthetic data is like it doesn't push SOTA, which means it doesn't push the state-of-the-art models. So we only kind of can have smaller model that can perform really well on a specific tasks using bigger model. And we are seeing recently with the hype of DeepSeek, the RL with verifiable rewards. So it is actually true RL because there is like you can see planning and all of this kind of stuff. No data issues because we don't need actually that many data because the LLM is trying to come up with his own chain of thoughts, and then I will just explain in a bit. And then actually it works. We are seeing a lot of DeepSeek R1 is really good models. OpenAI OI series, they are really good models in terms of reasoning. And then we saw that they are pushing the state of the art now, sort of. So yeah, so that's why we're gonna just like deep dive more a bit into RL with verifiable outputs. Um, Now we're gonna talk a bit more about DeepSeek. And then they were the first kind of it was the first paper that actually open source the way they trained their reasoning models. And then actually, if you read the paper, they didn't get DeepSeek R1 straight away. They trained something called DeepSeek R10, they called it. It was like kind of the first version of the reasoning model that they have, but they faced some issues. Um, some of the issues that they faced is like just to give you an idea, again, what DeepSeek did is they have another model called DeepSeek Bayes V3, which is a pre-trained models, not trained to follow any instruction. And they took that Bayes model and then they got some mathematical problems, and they tried to just use RL as scale to train that models without providing the actual outputs for that models. And what they did is like they took that base model and they kind of had their own reward function, and then their own reward function consisted of two things mainly. So they will reward the model if the model is actually following the format that the model is intended to generate the output in that format. For instance, if the model is returning the output and then the reasoning is within or the thinking is within the thinking tags, they will get a good reward for the model. And then if the actual output is correct as well, they will get another rewards. And then if the and then the and vice versa as well. So if the model doesn't return the output in that format, he will get negative rewards and kind of stuff like that. And they showed us something called GPRO, which is kind of reinforcement learning policy, where like the LLM can, based on that reward function that I talked about, the LLM will learn to maximize the likelihood of the cumulative reward function in the long run, and then the LLM is trying to think before actually providing an answer, and then they reach something called aha moment, which I'll talk about in a minute. But the issues that they faced with that is like the model was like actually not returning the output in a readable format. So it was in the correct format, but not in a readable format. And then the most of the time the model was like trying to mix between Chinese and English. And then even if the output is only an English sentence, the model is trying to respond in Chinese. So what they did in DeepSeek R1 is they start with something called cold start SFT data, where like they start with that, they fine tune that Bayes model on that, and then after that they did the same in terms of RL. This is in a nutshell again, because explaining the paper is gonna have its own session, by the way. Um, and on the paper, like we saw the results, as you can see on the screen. We kind of on the right, you can see that with time and then with training steps, the LLM is learning to produce much larger chain of thoughts. So the LLM is taking much longer to think about any problem before actually trying to answer that problem. And on the left, you can see the comparison between O1 and then R1 models, and then you can see how with time again, like the plotted lines, they are like the ones for OpenAI models, and then the other one, like the red and blue one, is the R1 model with training steps, and then you can see how R1 outperformed the O1 model on this specific data sets. Again, RL with reward function, cold start SFT data, and then RL, it showed that it worked. it works. And after that, they did some distillation from DeepSeek R1 using some model from Queen, which is model from Alibaba, and Llama, which is a model from Llama, to actually distill that thinking to smaller model, and then this model performed really well on different benchmarks as well. Does anyone have any question regarding DeepSeek and RL for um, training on large chain of thoughts? Nope. Okay. Um, right. And just to give you an idea about the the policy that they use to train that models again in a visual manner. So again, they took the DeepSeek V3 base, and again, they used a large-scale reinforcement learning to teach the model to think. And what they did is like they would have a training prompts. For instance, this is just an example. Write a Python code that takes a list of numbers, return them in a sorted order, but also add 42 at the start. Um, they will generate, I would say, n samples from the same prompts at each time. And you can see on the screen they generated four, but this is something that it can be configurable, and then as you will see next in the notebook, well, like you can specify that parameters, and then they had a rule-based verification. For instance, if is the output is actually a code, yes or no. If it is yes, even if the code is not in like really good format, and then the code is not executable or something, as long as it is a code, yeah, the model will get will get a reward, which means the model is we are forcing the model to learn that he must generate a code in this section. Is it Python? Again, if the model try to generate JavaScript, like the model, like the output is correct based on what the prompt is saying, but it's not Python, so the model can get either good reward and bad rewards. Pass unit test or not. So then actually now we can see like they would actually execute that code, and then if the output is the same as in the ground truth, the LLM will get like again positive rewards as well. And then from these generated responses, the LM will kind of optimize his policy to learn with time to generate a good chain of thoughts and eventually find an answer. And I included these links at the bottom, so I encourage everyone to go and take a look at this blog as well, where like they explain in details how it is being happened. So as you can see on the screen, for instance, for these four generated response, one of them it gave like really high rewards. So they actually went again to the actual checkpoints, and then they optimized that policy. They optimized that policy to force the model to generate the correct response at all the time with a larger chain of thoughts. And this is happening through training steps. You can think of kind of on like epochs or something. So like they would just want to obviously it's not like from the first time. You just have to keep training it. So this is, I would say, the RL large scale RL for LLMs in the nutshell. And then we'll see in the notebooks how it's being executed cell by cell. Again, I won't run at each one because it's going to take time. You can feel free to run it on. It is on Colab, by the way, so anyone can use it. So yeah, do you have any questions, guys?
Khalil, you're only sharing the slide, not the notebook, right?
Yes. As I said,
Okay.
it's going to be after that. So. But hopefully you got the idea of how they are using RL on um, with LLMs. Um,
Yep.
this is, I would say, the theory part because I don't want to go through all like over the math because it's gonna get really complicated. But this is how, like in a visual, I would say, kind of representation, how they are like giving that model a reward, and then it is like, as I said, it can be anything. Like for instance, if you want to teach a model to generate like good SQLs, like do you want to build an application that you want to generate a SQL given a text, what you can do is like you can, for instance, your reward function can be is the output is in an SQL statements, yes or no? Is the output is in the correct format if the model if putting the SQL statement within SQL tags, yes or no? Does the SQL actually runs, yes or no? This can be another point you can give to the LLM. Does the query runs under 1 or 2 seconds, whatever? Yes or no? Is it slow or bad? Yes or no? All of this kind of stuff you can actually construct, and then using GRPO, the algorithm that DeepSeek showed us how to use. You can force the mo You can build your own reasoning. You can build your own reasoning models of any data set essentially you want or any use case, and then it doesn't have to be like large models. It's essentially can be a small model as well, as we will see in the notebook. Does anyone have any question regarding the RL, large scale RL, I would say?
Yeah, I have one question.
Yes, please.
Yeah, so based on what we measure how good or the bad the behavior of the agent is. For example, you mentioned if it's high or low. Like from where we get these levels, like the high and the low.
As I said, it's something that you describe. So if I go one slide back, it's like rule-based verifications. So again, if you're trying to make a model that is really good at writing Python and solving a problem using Python, you can give it like a reward function if it like, for instance, 0 0.5 if the provided is an actually out a code. Is it Python? Does it pass unit test? And can it run within 10 seconds? Can it run within 5 seconds? All of this kind of reward functions you specify as we'll see in the notebook now. And then you pass it by to the trainers. And that's how you are telling the model how, or how that's how you are giving a score to the generated output.
Okay, what is the unit test exactly?
So unit test is like like if you're writing any function, you can write a unit test as well. This is important because like when you want, let's say you have really large code base, and then if you have like different functions and stuff, if you write a unit test for that function, so like when someone push to production, for instance, you want to make sure even if you are adding new stuff, the old stuff doesn't get affected. So if you have a function that, for instance, takes two input, A and B, and then they are integer. And if like the essentially what the function is doing is just like doing, let's say, addition, like A plus B, it will return A plus B. And a unit test is like really easy. You can write a unit test function that will test that function in different scenarios, like and then this is something that you specify. Like unit test is like, I want to test this function if the input is 1, and then A is 1, and then B is 2, so the output is 3. If the function returns 3, which means it passes the unit test. Make sense?
Okay, like
I
it's
can add
specific.
something also to what you mentioned, Khalil. Hassan, in a nutshell or in simple words, unit test is a function that is always there to validate that your main function is working correctly. So if the unit test fails, or if the unit test is another function where it makes sure that the first function is working correctly. If it fails, then this is a sign for you that the function, the main one, is not working correctly, and then you have to get back and edit it to work correctly.
Yeah.
Make
And in,
sense?
in Python, for instance, like like you can pass, even if a function is expecting integer, you can pass a string, for instance. So you want to test it. If you pass a string, what should happen? If you specify that if you pass a string, it should return none. But if it return something different than none, so there is something wrong, and then you have to go and fix it.
Yeah, so this small function can reflect whether the whole code we have it's functional or not. Maybe.
Yes, exactly. And obviously, you can use it in when building reasoning models that can generate code. You can see you want to check if the generated code from the LLM is passing the test or not.
Yeah, okay, thanks a lot.
Do you have any other questions, guys?
Okay, yes, Khalil.
Yes.
Uh, okay. Hala, now, for example, you are presenting a simple example, but in
Yes.
fact, LLM do a trillion of solution. And in programming, we have, for example, more than 1,000 language. In
Yeah.
life, we have more than 1,000 solution. In physics, in math, in in astronomy, and I don't know. So
Yes.
or this or this training was done by a human. For example, they prepare all this and start rewarding yes no, because as you know, يعني, LLM, he can write function coding, maybe need someone expert in 13 years in coding. It's maybe the picture is very simple, but in fact they are doing huge work.
Yeah,
So
I mean, I didn't say that it is like really, really simple. Like the idea is simple, yes, but the actual implementation is not, because you need to actually have a data sets that will, like, for instance, with in order to reward the model to give it the rewards. So like we'll see in the example later, we will be using something called GSMK datasets, which has the input and output. Um, and yes, obviously, like like we are actually teaching the model to think. The main idea is like we're gonna teach the model to take his time in thinking and generating chain of thoughts before actually reaching a point where like the model will return the output. And then actually, because if I go in here and then I think I have the DeepSeek paper open, yeah, I will show you an example on like we call it the aha moments, where like this is one of the functions or one of the questions that appeared in the data sets that they used for training. If A is bigger than B, then the sum of the real solution of blah 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 is equal x, equal x is equal to. And then in the response, the model was like reach a model where like the model tried to, based on the previous generated tokens, the model said, aha, I did a mistake, so I need to reevaluate my solution and then I can give an answer. So, and this is happening again using the reward function that is being used or like treated for the models. So, and then if I go over again the actual prompt that they use to construct the initial input is it's really simple. Like if conversation between user and agent, the user asks a question and the assistant solves it. The assistant first thinks about the reasoning process in the mind, and then provide the user with the answers. The reasoning process as answers are enclosed in within thinking tags, and the answer is within answering tags. And then they put the prompt in here in the red, and then the assistant will reply after that. So they constructed the I would say system prompts or the initial prompt in that way. And then as you can see, the reward function for them was like the accuracy rewards and then the format. So for instance, the accuracy reward model evaluate whenever the response is correct. For example, in case of the math problems with the deterministic results, the model is required to provide the final answer in a specific format within a box using a mathematical formula, enabling readable rule-based verification of correctnesses. Similarly, lead code problem, because as you know, like if you go and provide any code through lead code, you can compile it, you can see if it will pass the unit test or not. So the idea here is like, yes, you would have a prompt or like a data sets with a initial prompt and computation, but you won't have the actual thinking or the reason why this should be the output. The model is learning again using, if you take a look at this chart, that the chain of thoughts, length of the chain of thoughts is increasing with time. So the model is learning to think more before actually providing a final response. Does that make sense?
okay, fine. One more question. For example,
Yes.
the LLM, they are teach rule. For example, what is the cosine of 10? What if the
Yes.
logarithm? They have, for example, a predefined function, and we teach him this function like, for example, it's working
Uh,
like this internally, or just the data and pattern.
So as I said, they start from a base model, and then the base model is trained over all the internet, which means the LLM knows exactly what is cosine. Like the LLM has an idea of what does cosine mean. Yeah, but in the reasoning or post-training reasoning process, they give him the prompt and then they give him the output without explicitly saying why this is the output or without providing any explanation. And they trained it using the reinforcement learning approach that I just described. And then the LLM will try to think about the answer before answering. But to answer your questions, the LLM is learning what does cosine mean from the pre-training stage, not from the post-training stage.
Okay, so no formulas were teach to the LLM
Well,
or no?
they are being taught but in the pre-training stage because they read the whole internet basically. So
Okay.
in an unsupervised way, yes. Make sense?
Thank you. Thank you.
Because now, for instance, like if you go to ChatGPT and say like, what is the capital of Lebanon? The LLM knows that the capital of Lebanon is Beirut because the data that the LLM saw in the pre-training stage, like when they used the crawlers to train that LLM. So this is knowledge that has been acquired from the pre-training stage, not specifically in that stage, in this stage.
Okay.
Yeah,
Okay.
I hope this answers your question.
Yes, yes.
Okay. Does anyone have any other questions? Feel free to ask me anything. If not, we're gonna go over this notebook.
I
This
think,
notebook,
sure,
yeah.
Khalil. Hassan, do you have any question?
Um, maybe like I have a question like is the large language model have direct access to the internet or just like they do the crawling part and then uh, like it's not they don't like not in the same data set. I don't know if you get my point. Like should they have direct access to the internet or the data already they have the data set already?
So you're talking about during training or inference?
Like yeah, before the training. Like or maybe yeah, during the training, like as you mentioned, they get the information from the pre-trained, not from the post.
Yeah. So I mean, obviously, like the LLM doesn't have direct access to the internet. I mean, at the inference time, obviously, if you go to ChatGPT, you can see you have search the internet button where like you can press it, and then the LLM will kind of try and go and search the internet. But uh, I think you mentioned the crawlers. So the crawlers, they are like a human made, and they are like functions that run every day to crawl the new data from the internet that has been indexed by search engines such as Google, Bing's, DuckDuckGo, whatever. And these data is being used to train the LLM, if that makes sense.
Okay, so so do they save this data set that already crawled by the crawlers?
Yeah. It,
Okay.
yeah, it's in terabytes of data, like really, really big, and they use that data in an unsupervised way in the pre-training stage to teach the LLM or to teach the LLM how to model the language, if that makes sense.
Yeah, yeah. Okay, thanks.
Any other question before we go over the notebook? So yeah, this is like I would say really straightforward notebooks. It has been provided by Hugging Face and a company called Ansloth. They are a company that
Excuse me, Khalil, if you can zoom the screen a little bit, please.
yeah, sure. Oops. Can you see
Thank you
now?
so much. I think
Yeah.
it's better. Yeah, I think it's better.
Yeah. So this company is they enable us to fine-tune models by using less GPU footage, and they have a paid version, but the paid version is like us how we can and essentially teach it to reason. So we start with actually installing the dependencies, and the reason why I chose Notebook because like over different machines and different, for instance, CUDA or pip or whatever, the installation will be different. But I think when you run this on a notebook, you can, it's kind of it will work. So what you have to do is like you have to connect, and then when you connect, make sure you choose that you want to have a T4 GPU. Otherwise, it's I think the default is CPU. So make sure you choose GPU. So the way you do it is like when you press connect in here, press on the button, change runtime, just change runtime type, and then choose a T4 GPU. So you would have access to the GPU. This notebook will have access to the GPU for free. And you have to install the requirements. As you can see, they are installing N plus and VLLM, which kind of way to run inference faster as well. And you kind of have to install because they are using Gamma model from Microsoft, which has been released like 2 weeks ago or something. You have to install the transformer version which have this model. After that, you have to initialize the model. You load the fast model interface. As you can see, you can choose any of these. You can choose Llama 8B if you would like. You can choose Gamma and whatever. In this notebook, they chose Gamma 3 1B instruct model. 1B is like 1 billion parameters, so it's like really tiny model. And then they specify that the maximum length is 1024. Bear in mind, like if you want to increase that, which means you need more GPUs. So just to make sure, you can't just like set this to 128K and then expect this to run. So just to make sure you are careful with this. And there are some other parameters that you can play with. For instance, load in 4B, load in 8B. So like if you want to quantize the model to make it like take less space in the GPU as well. And then there is something called full fine tuning. And then this is like because they will be like when we fine tune, we use something called TEFT or LoRa and LoRa adapters, which essentially is like to fine tune a small section of the model rather than the full fine tuning. And this is where they initialize the PEFT section. So as you can see, fine-tune vision layer. You can say yes or no. Fine-tune language layers. Fine-tune attention layers. Fine-tune the MLP layer. So this is all kind of like a section inside the transformer. And R and LoRa Alpha, they are like something related to the LoRa fine-tuning, which I think it needs like a whole section by itself to explain what kind of all of this stuff is. But for now, you can just keep it as you can keep them as they are. Data preparation, they're using the open data sets from OpenAI. It's called GSMK. So if I go to the data sets, you can see we have question and answer, and they are kind of like math questions. Okay, we'll have soon a complete course on yeah. I'm sure Lara will teach you how to do it. Um, so and then you have the question and answer, and the answer is like, as you can see the answer is like they have some explanation in here, and then the final answer is after some hashtags. And so they load the training set, and they want to extract the hash answer because as I said, we just want to use reinforcement learning, and then we don't want to show the model this thinking section just yet. So they extract this, and they want as like if I go to the paper in here, as you can see in here, they use this template for the training, but in this notebook they just decided to go with different one. For instance, you are given a problem, think about the problem and provide your working out. Place it in, and then they specified how the model should put the final output is in. So they are forcing the model to put the final output in a reasoning start working out and working out, and the solution should be within the solution tags. They construct the whole data set again. So as you can see, the question would be like the one that you can see on the first line, and then the final answer is this one. So the prompt is like they just have this one, and this is the system prompt essentially for each one of this. The reward function. Now that you were asking before, in here they created a regex, and the regex is a way that you can, it's like strings in Python, right? They want to check if they have reasoning start and reasoning end, solution start, solution end, and they want to check if the no if like they want to give a reward function again to the model if they are putting it in the right format. And then after that, they want to count. They want to again check if they have like the the tags that they provided before. If they have one, like for instance, if restaurant.count equal one, they want to give the score for the model, which is 0.5. Otherwise, mine is 0.5. That's how they construct the score for the model. And then at the end, they actually want to check the actual output. So finally, we want to extract the generated answers and rewards or penalize it. We will also reward if it based on it was close to the original answer. So this is like again functions that you as a user you provide. That for instance it takes prompt computation answers and then it checks the answer if it is the correct one or not. And that's essentially it, I would say. So like they are rewarding here the model if the model is actually returning the correct answer at the end, as you can see 16, 41. So like in this data set is I think I think it's mostly actual number. So they are getting this prompt, checking the final output from the LLM, and then checking if the LLM is putting the output in the correct format. And that's essentially it. That's how they are constructing the GPRO trainer, and that does all of the heavy lifting under the hood for the reinforcement learning parts. It is providing from TRL, which is from Hugging Face as well. And as you can see on the screen, number of generation in here is 4. So if I go to the slides again, you can see generate 4 response. So if you increase this, you're gonna essentially take more memory in the GPU. So you can essentially keep it as 4 now, but you can increase it as well. And then all of the kind of normal stuff like from the learning rate and this stuff, you can just keep it as they are. And then you start the training process. Um, I think they specified maximum step is 50, and I think they said if you want to actually reach the aha moment, which is this moment, like where the model learned that in the middle of the generation that he did something wrong, is you can like, kind of you need like instead of maximum step 50, you kind of increase it to 500 or something. Um, and then they start the training. As you can see, this is like the during training, this is how the model is trying to generate the answer. And after that, they just like run the inference, and the essentially model is learning to put his thinking within the thinking tags, and then the model is generating the correct answer. And at the end, they are saving the models using the save pre-trained function from Hugging Face. And if you want to kind of save it in float 16 as a quantized version to make it run faster and to make it run with VLLM at the end, you can do that as well. And you can push it to Hugging Face Hub as well if you want to put it online on Hugging Face. Um, that's essentially it. Again, I'm not gonna run it because it's gonna take time. Internally, like I have access to some bigger GPUs. I trained this, and but I increased this to I think 500 and then or 1000. I'm not sure. It took like, and then I increased this to 8 or 16. It took like 10 hours to train, but it
Oh,
was one
wow.
GPU. One GPU. So yeah, hopefully you will go
Khalil,
and yeah,
yeah, excuse me for interruption, but I don't want to miss it. One GPU, what was the type and the size of the GPU that you used to train this one on the larger size, of course, that you mentioned?
yeah, sure. I can go actually and show you. It was ML8X. Uh,
Okay, okay, on AWS. It's on Bedrock
yeah,
or SageMaker?
it's on SageMaker.
Yeah,
Um,
okay.
so if I go to the notebooks that I used this one. So this one. It is, where is it? Yeah, ML5 5G X8X large.
Okay.
So if I go and do, I think it has 24 gigabyte of memory. SageMaker, let's say pricing, because they will show us all of this kind of stuff in here. Is it net? Yes. This. So as you can see, like virtual CPU is 32, instance memory 128, RAM, GPU model NVIDIA A100G, number of GPU is one, total GPU per total GPU memory GB is 24. So yeah.
Okay. Makes sense.
Um,
Yeah, but it took 10 hours, like, and if we add two or three, maybe it will take less time, or it's not necessary.
so you mean like two or three in terms of the number of
GPUs.
generation
No, I mean
GPUs?
GPUs. Yeah.
I mean, like, if you use again, it won't work with this because if you wanna use multi GPU using this company, you have to pay for them. But actually, you don't
Oh, I
have to
see.
use them. You don't have to use them because Hugging Face have their own. Like, you can use actually the what is that? GRPO trainer without using the unsloth configuration.
Hmm.
It's gonna take more GPUs, but obviously, if you have multi GPUs, you can distribute the training as well, and then it can take less time, but
Okay, makes
you can
sense.
pay more money. So
Yeah,
um,
makes sense.
yeah, so yeah, I will send the link for this as well, and I will send the presentation, and I will send the link um, for the DeepMind one as well. And yeah, I think it is Q&A sections, guys. If you have any Q&A, I'm happy to answer. Anything related to AI, not AI, whatever, happy to answer.
First of all, thank you so much, Khalil. This was really an interesting session. On the
Thank you.
personal level, I found it really, really helpful. And now I leave the door open for all the community. If anyone has any questions, please feel free either to drop them in the DMs or just open the mic and feel free to ask Khalil anything.
Yep.
Hi, Khalil. Okay. Uh,
Yeah.
yes. I am thinking for now, why, for example, now we are need to read the internet to start reply by LM. For example, why we are not thinking to start teaching him or it rules to start generating. For example, we are let him to read 1,000 book of math to
Yeah.
maybe generate one output. For example, we can teach him with one book like uh, human. We are
Yeah.
we are teach by one book, and we can generate multiple theory. Why till now the science they don't think to teach him rules, not for example read raw data from a trillion book, for example.
Well, first of all, like, if you want to do that, you can obviously do it, but the LLM won't have the capability of being as an assistant, and the LLM will only think or can answer from the data that you provided, and it's going to be like really low level, I would say, because they have something called there's like really interesting paper called chinchilla paper, where like they proved already that with the transformer we actually didn't reach something with the plateau yet, which means more data with more compute will always generate more results. So we are not trying to just build something that is really good at math or really good at Python or whatever. We are trying to build like a really true assistants that are, I would say, human level assistants, and because you can you can obviously, yeah, teach a model that to read all of the math book and stuff, but the this assistant will only know about math. So if you go to that, ask him what is this in my hand, my Apple Watch. The LM won't know anything about it because the LM didn't see it before. While we teach it on the we use the whole internet because it's like this is where all of the data can come from, right? And then because it's an unsupervised way in the pre-training stage, they just have to get the data, filter it, put it in the right format, and that's it. They can start training. Um, so I hope this answered your question. And so we are trying to build an assistant, like a human level assistant, like close to AGI, not an LLM that is really good at solving one task, but rather than like a general assistant that can learn from the interaction with the environments and answer any question you ask.
Okay, but this data, of course, she has repetitive data, of course. They are filtering this repetitive data
Of
because the full
when
internet is not it's not unique data, of course. When we say
if you so like I already did like a session about how they actually train LLMs. It is on YouTube. I'm gonna send the link later. But if I go to if I show you one of the slides that I had is okay. Um, where is that? Okay, so the data. And as a train over all the internet, common crawler 250 billion page, and then it's being increased every month. They filter the data. First of all, they remove the HTML tags because this is from the internet, so they want to kind of remove all of the HTML tags. They remove the PII, which is the personally identified sections of the data, like names, phone numbers, and all of this kind of stuff. Remove duplicate data. Again, they remove the duplicate data, and then they do some heuristic filtering and model-based filtering and upweight some domains. So yes, they remove the duplicate data, or they try to do that as much as they can.
okay, thank you.
Yeah. And this is the chinchilla paper that I was like trying to talk about. Is like we didn't reach the plateau yet, and then they kind of predict how the model will perform based on the number of the like data that we have, how many tokens in our vocabulary, and the resources that we have. So like for how long can we train that model for? So yeah, they can predict the actual they can predict the accuracy of the training loss, if that makes sense. Which is like really interesting for me at least. So
Okay, thank you, thank you.
um so yeah.
Hello, Khalil. Thank you for your time for the presentation.
Thank you.
You said before you work as a software engineer, then you shift career into AI. Would I
Yeah.
ask what make you shift your career? Do you think now AI is more interesting field than software?
Well, I mean, AI is still I wanted to say something, but because it's being recorded anyway, but I can't say it. Maybe I can say it when it's not being recorded. But um, to work as a machine learning engineer, you have to like big companies now currently when they hire for machine learning engineer roles, they say they are hiring for software engineer in machine learning engineer specialty. So any software engineer can be a machine learning engineer if he just studied more and just give him like his knowledge about X, Y, and Z. Because at the end of the day, we are building software, and um, you are trying you kind of want to make it useful for other people and then put it online, build, I don't know, back end, so whatever, like a cool front end, and make it scalable. For instance, even like when you deal with the cloud, you are still doing software engineering because you are creating softwares, you are engineering softwares, right? Um, what made me actually kind of want to be specialized in this field is like even as I said, I was like doing computer and communication engineering, which is not a actually pure software engineering. Um, like I was like studying all of this, everything related to networking, switches, hubs, fiber optics, and I had some software courses in the university, but I was like mostly interested in softwares, and then some part of me was like interested in robotics. So I did my thesis at the end, and I've built like a small robot where like I used both the hardware and then the software skills in order to build that robot. And then obviously when you deal with robots, you're dealing with intelligence machines, so you want to kind of build an intelligence robot, right? Um, And then from then I decided that I wanna be I can see that this field is gonna be the next big things, and then I want to be in that field. So I had like even from before that I had like really I was like really inspired with actually I have like a really cool video on YouTube. It is actually on um AWS channel. So where is this? I'm gonna look it for you and then send it because like it's actually on AWS, Amazon Web Services big channel with more than a million subscribers. Well, like they were asking me, oh, why you wanted to do this as well, and then I answered the same question, and then I will re-answer it again. Like I was like fascinated when I saw that how machine can see the difference between cat and dogs, or how recommendation system works, how the machine like we have on our phones, Siri, for instance, how Siri can understand our language. So I was like really fascinated with all of this stuff. So even again, before the AI bomb in 2019, I got my first AI book and I started studying the classification supervised and supervised learning. And then they were all new things to me. Like I didn't know anything about them. And on that point of on my life, I decided that I'm gonna carry on with because it was back then the only way to be specialized in this is like actually and go to and then because my dream was like to come and work and live in London. The only way that I need to come and live in London and to be specialized in this is like doing actually a master. So that's why I did a master's degree in AI, and with time, like I was like I found myself really enjoying what I'm doing, like really, really enjoying. So yeah, that's how I ended up being doing what I want to do, if that makes sense. So and then I think anyone can translate to this field, like literally anyone. If you just, but you have to put the effort. Like there is no talk about this. Like you have to just to make sure you are putting the effort, putting part of your day, try to expand your knowledge, try to explore something new. It's always exploration and exploitation. So yeah. It is, I would say, even all of the people that I work with, like even like my university in Lebanon, the university in the UK, by working with other nationalities and British people and all of the stuff, and then even the place where I work now at Firemind or either AWS. They say that my curiosity is the thing that can distinguish between me and other people because I'm really curious about stuff. Even if I don't know anything about a subject, I'm not afraid of going and exploring it, and then I'm not afraid of saying that I don't know, if that makes sense. But the thing that I know is like I know that if I put the right effort, I will end up learning all of this stuff. So
Yeah, that
I'm so
totally makes
happy
sense.
that you live where you want to be. I have a small question.
yeah.
Go more deep in this field, the reinforcement with RLM. Do you think there is a framework, library, article, documentation we should go through?
I mean, I put if you wanna start like with this one, I would say. Um, So if you go in here, um, you can kind of read more about the oh not oh sorry not this one, this one. You can read more about the actual like explanation in more details than the I did in the presentation on how they. Oops, why it's not being found? I will make sure but I'm sure I put this one in there. Um, Never mind. I will. I think it is this one. Yes, it is this one. Um, you can go over this in more details. They explain like a lot of kind of stuff. Regarding pure reinforcement learning, I would say if you watch the documentary that I will send later, so which is okay, DeepMind AlphaGo documentary. Yeah, if you watch this movie, I'll send it like literally now in the chat. Yeah, it's 1.5. You can share it, please. Which one you mean? This one? I will share it in here as well.
Yes, please.
Um, okay, even this one as well. I'll share it in here, and then I will share the presentation later. If you watch this as well, you can even if even that they don't go over like details of the actual network and stuff, but you can see how it started all and stuff, like actual reinforcement learning. And after that, you can read more about it. You can read about something called DQA paper. Is it this one? Reinforcement learning. There's is it DQA or I forgot to be honest. I forgot to be honest, but I'm gonna get back to you on this. But yeah, I will try to provide you with the other resources and stuff. There is an actually cool library, and then actually I met the because like you know when you live in London, you can sometimes meet a lot of interesting people. So the person who works on this library is called RL from PyTorch framework. I've met the guys who maintain this library in London by chance, and I will send this to the chat as well. Maybe if you are curious as well, you can go through the documentation. You can see how you can actually build a reinforcement learning agent using this library, and then it doesn't take compute, right? Okay, DQN, sorry, DQN. This is the paper because I remember reading this when I was undergrad. DQN algorithm. DQN is deep Q learning. Yes, that's it. Oops, deep Q learning paper. Yes, this is the paper where like the DeepMind showed to all of us or like the whole world that they can teach a model to play an Atari game by just like literally looking at the pixels. Yeah, it's really interesting to be honest. It's a small paper and you can read more about it maybe. But yeah, um, yeah,
If you can
reinforcement
also
learning
send us,
is
please, excuse me,
Sandy.
yes, this GitHub, and we could have another session and read more about this paper and maybe try this repository or something.
Yeah, sure, definitely. Um, But yeah, reinforcement learning is like a really cool topic. And again, I think it's not only gonna stop at LLMs, but even building actual robotics. I don't know you guys if you know if you saw what NVIDIA released. They were like they always releasing like some frameworks related to building actual robots, and then obviously reinforcement learning is gonna be like the next hot topic as well. So cool.
Okay. I think we came to the end of the session. Thank you so much, Khalil, for your time, and thank you for
Thank
everyone
you.
who attended. As I mentioned on the personal level, it was and it's really a fruitful session. Thank you so much.
Welcome.
Let me stop the recording.